Hello, this is the luckiest maths teacher in the world teaching you today about factorisation, which is actually the opposite of what we did last time, which was expanding brackets using the distributive law. But before we actually get into how to factorise, we need to know about highest common factor. So we're just going to have a quick review of that. So you would have learned about highest common factor before. You probably would have done it when you did factors and multiples, but it's also needed when you want to simplify fractions. Remember, you had to find the highest common factor of the numerator and the denominator. So the highest common factor of two or more numbers is just the largest number that goes into those numbers. So let's say, for example, we wanted to find, I'm just going to abbreviate it, highest common factor of, let's say, 10 and 15. So we want to find the highest number that is a factor of 10 and also a factor of 15. So what we can do is we can write out factors of 10. Just write out a few of those. So these are, of course, all the numbers that go into 10. Remember, factors are always less than or equal to the number. Don't get them confused with multiples. So 1's a factor of every number. And then, of course, 2 goes into 10, 3 and 4 don't, 5 does, and so does 10. And if I wanted to write factors of 15, again, it's the numbers that go into 15. So 1 does, 2 doesn't, 3 goes into 15, 5 goes into 15, and there are no other factors besides 15 itself. So the highest common factor of 10 and 15 is obviously 5, because it is the highest number that is a factor of 10 and 15. 1 is a factor of 10 and a factor of 15, but it's not the highest number that's a factor of both numbers. So we say the highest common factor of 10 and 15 is 5. Sometimes the highest common factor of two numbers will be one of the numbers. So for example, the highest common factor of 8 and 24, because 8 actually goes into 24, it must be 8. I can do that without writing out factors. So don't worry, I'm not going to give you some really obscure numbers like find the highest common factor of 202 and 4,986 or whatever. It's just going to be small numbers and you'll be able to write out the factors of each number. So if you really don't remember factors and you need more help with that, please make sure you ask, because we're actually going to take this a step further. So you've already learned about highest common factors with numbers, but we're going to look at highest common factors where it's not just numbers, it's also letters as well. So I'm about to rub off these examples. Please copy them down if you need. So to be able to do factorisation properly, we're going to be able to need to find things like the highest common factor of 4x and 6. Okay? So the highest common factor can be a number, it can be a letter, it could be a combination of both. So what we do is we first look at the highest common factor of the number parts of each of this. So we're going to look at the highest common factor of 4 and 6. Now hopefully it won't take you too long to figure out that the highest common factor of 4 and 6 is 2. Then what you do is you write any letters that are common to both of the things, both of the terms. So there's an x in the first term, 4x, but not in the second. They have no letters in common, this term and this term, so we're done. But sometimes they will have a letter in common. So let's try and find the highest common factor of, let's say, 7y and 21y. So first, the highest common factor of 7 and 21, well, 7 goes into 21, so it must be 7. But there's also a y in both of these terms. So the highest common factor is 7y. Let's say I wanted to find the highest common factor of 10xy and 25y squared. Okay, so again, I look at the numbers 10 and 25. What's the highest common factor? Hopefully it won't take you too long to figure out that the highest common factor of 10 and 25 is 5. Now I write any letters that are common. So a y is common to both of these. Now the 25y squared means it has two y's, but the first one only has one y. So that's why I'm only writing one y there as well. Sometimes you'll have to deal with negatives too, which is annoying. So if I have to find the highest common factor of, let's say, minus 6x squared y and let's say minus 15 x squared. So here, the highest common factor of 6 and 15, so again, hopefully it doesn't take too long, is 3. But because they're both negative, I take the negative as the highest common factor. Now that's just because that's going to help us simplify things when we factorize. Now here, this term has an x squared. This also has an x squared. So the highest common factor is negative 3x squared. There are two x's in both of them. All right, now we're going to use this to find out how we factorize. So in our last video, we looked at things like this. We had a question like 4x plus 3, and if we expand the brackets using the distributive law, it's 4 times x, 4 times 3, and then a plus in the middle. Now, when we go this way, which is what we did last time, that's using the distributive law, to expand. So we start off with brackets and then we end up with no brackets. But what we're doing today is we're going the other way. We're going to start off with an expression like this and we're going to factorize it. So when you factorize, it means you write it as something times something. So this time you're going to start off with something that has no brackets and your answer will have brackets. Now what you do is you need to divide each term by the highest common factor of the terms. That's what goes outside the brackets. So let's have an example. Let's say I want to do 9x plus 21. So this isn't too difficult. Now, because I want to factorize it, I want it to be something times something. This second thing will have brackets. So what goes here outside the brackets, as I said, is the highest common factor of the two terms, 9x and 21. So the highest common factor of 9 and 21 is 3. There are no letters in common. So then what goes in the brackets? Well, the first term that goes in the brackets is this divided by the highest common factor. 9x divided by 3, that gives you 3x. Then our next thing is positive 21 divided by, again, the highest common factor. That is positive 7. So what's happened is I have now made this thing without brackets into something that has brackets, and it's something times something. If I were to expand this here, I would get my original answer of 9x plus 21, so my original expression. Because expanding and factorizing undo each other exactly the same way that multiplication and division undo each other. So let's have a go at another example. So let's say I have 6x squared minus 14x. So I take the highest common factor and put it out the front. So the highest common factor of 6 and 14 is 2. There's also an x in both terms. And then what goes inside the brackets? I have, what do I times by 2x to get 6x squared? I must times it by 3x. What do I times by 2x to get negative 14x? If you like, I'm also asking what is negative 14x divide 2x? And that just becomes minus 7. So again, if I expand this expression, I will get the thing I originally started with. So let's try another example. Let's say I have minus 9x minus 36y. So again, both of these are negative. The highest common factor of 9 and 36 is 9, but I want to take out a negative 9 to make it easier. Now, there are no letters in common with both terms. One has an x, one has a y. So I'm done with my highest common factor there. So I say, what do I times by negative 9 to get negative 9x? Or if you like, what's negative 9x divide negative 9? So that's just x, because 9 times x, or negative 9 times x gives me this term here. And then I think, what do I need to multiply by 9, or negative 9, to get negative 36y? So to get this, I need to multiply by positive 4, because negative 9 times positive 4 gives me negative 36. And then I also need the y in there as well. So as you can see in all of these examples, I've started off with an expression without brackets, and then I've made it into something that does have brackets. It's something times something. Okay, I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.